Welcome. Let's solve Leetcode 2593. Find score of an array after marking all elements. They give us an array nums consisting of positive integers. Starting with score equals 0, apply the following algorithm. Choose the smallest integer of the array that is not marked. If there is a tie, choose the one with the smallest index. So when I read something like this, I think of a heap, where we can use the heap to first store it by the smallest integer, and then the second value would be the index, and we'll let the heap deal with both of those criteria for determining the smallest integer. Next part of the algorithm says to add the value of the chosen integer to score. Mark the chosen element and its two adjacent elements if they exist, and repeat until all the elements in the array are marked. Return the score you get after applying the algorithm. Okay, so let's look at maybe this one here, this example. So the array or the list of numbers, positive integers, is 213452, and we mark the elements as follows. So in this list here, the smallest element is 1, so they remove 1 and they add it to the score. Next, 2 is the smallest unmarked element, so they mark it, and they also mark, we forgot to, for this part, we need to mark the elements to the left and the right. It says right here, choose the element and mark the chosen element and its two adjacent elements if they exist. So when we mark 1, we need to mark 2 and 3. So in my mind, I'm thinking that we should keep some sort of data structure that will indicate which elements are marked. Interesting. Next, so they remove 1 and they mark 2 and 3. They remove this 2 and they mark the 5, indicated by this underline here. And the last element left remaining is 4. And so only 1, 2, and 4 were contributed to the result, and the other marks were marked, so they were left unused. They did not contribute to the result. And so that's basically the problem statement. I find it straightforward. So there's a couple approaches we can take. We can either use a heap, which is maybe a little bit more obvious, but we can also use sorting. Let's use sorting because I think it'll provide a faster time complexity. All right, so let's start it. So let's go over how it'll work when we use sorting. Let's open it back up. Sorry. Let's copy one of these examples. Let's copy this example. It's fine. So this is the list array that they gave us, the numbers array. So what we'll do is we'll sort it. So what we want to do is we'll sort it, but then we also want to keep track of the index. So first we'll convert the array into a format that includes the index. So what we'll do is we'll do something like this. We'll loop through all of them. So we'll say for number in numbers, we'll just call this numbers. So for number of numbers, what we'll do is we'll use the enumerate function to help us extract the index as well as the number. So let's see, we'll store, so now that we have the index, and the number, we can make maybe a tuple, and we'll store the number and the index. And this will be, let me see. And we'll call this maybe the formatted numbers. And next we'll want to sort it, so we'll call this num sorted. So we'll call this maybe sorted formatted nums. So let's go over how this would look. So originally when we did performed line 5 here, what we would have is after this point here, before the sorting, we would have something like this. We'd have 2, 0. What is that? 3, 1. And I'm not going to do all of them, but maybe one more. I'll do 5, 2. That's what we have. And then the way Python works is that when we sort this, it'll automatically sort this by the first value in the tuple, and then it'll automatically sort, if there's a tie, it'll sort it by the second value here. So it'll sort it first by the actual value, and secondly by the index. And maybe we can let's demonstrate that. So let's do that right now. So let's say maybe we'll call this n equals length of nums. Sure, and let's do this here. Let's do for I in range n, and let's do like we did up there. We'll say nums. I don't want to keep writing nums, so I'll write n, and let's call this L. And we'll call this, so now we want to set a tuple for each of these, and the tuple needs to store the value and the index. So the value is n of I, and the index is I. And we'll look at this. We'll call this maybe, I don't know, we'll call this S. And this is, what is this? This will be this. So let's print the original list. So print F original. And then we'll print the sorted one. We'll put this here as, not sorted, it'll be formatted. Formatted. And let's run it. Let's return something just so it doesn't return 0. So let's look at that, what it looks like. So the original list is 213452, and now we've converted this list into a format that is more friendly for us, for our use case. Remember, we want the value and the index. So when we get the lowest number, when we get 1, we want to be able to jump to the proper index to update it as marked. Okay, so let's continue. So we sort it. Oh, sorry, let's sort it too. Let's say print F sorted, and we'll call this maybe sorted S. Great. This is good. This is good. So the original, and notice here sorted is 1 1, and now see here there's a tie here 2 0 and 2 5. It automatically sorted by the index first. So I wanted to make that point. Okay, great. Let's carry on. What are we doing now? So we've sorted it. Now what we can do is we can loop through all elements and mark that element as well as neighbors. So why do we sort it? Because remember, we wanted to, by the problem description, they tell us to choose the smallest integer. So by sorting it, we loop through it, we'll always have access to the smallest integer of the array. And one last thing is, remember we need to mark this element and the adjacent element. So we'll need something to store that. So we'll maybe have a, what we can do is we can do something like this. We'll say marked. Let's do a couple of things. Let's do marked. We'll call it a dict. Maybe even a set. Let's see, marked set. Yeah, that might work. Let's use marked set. So anytime we get the index, we'll put it in here, and we'll always perform a check if it's marked or not. Okay, so I think that's enough for us to get started. And sorry, while we loop through the elements, we'll add element to result. Okay, I think that's enough for us to get started. So we'll keep what we use so far. So let's take this. I'm going to clean it up a little bit. So I'm going to say, let's do this. So for, we'll call this n and I in sorted this here. Let's see. So let's see what we got here. So sorted, so we're formatting the array here, and then we're sorting it, and then we're just spitting out each element. So this first n value should be the number, and I should be the index. Okay. And then what we can do is just for educational purposes, let's print out what they look like. So print, we'll print ni, and let's run through it. Okay, great. So these are just those values. Okay, great. Now, what we want to do is we want to somehow keep track of our sorted. So there's a couple ways we're going to do this. I'll do the more direct approach and then the more clever approach next. So let's do like that. Marked equals set. Okay, so if I in marked continue. Otherwise, we want to add that number to the result. So let's set a result here. So result, and set it equal to 0. Otherwise, set result plus equals to that number. And now we need to mark 3 values. We need to mark possibly 3 values. We need to mark that value, the index before it, and the index after. So what we can do is we can do something like, so we sure need to do, for sure we need to say marked dot add I. And what we can do next is, well, let's mark the index afterwards. So I think this will work. Marked dot add I plus 1 and marked dot add I minus 1. Okay. Yeah, I think this should work. Is there anything else? And we can just return result. Let's check it. Okay, looks great. Let's submit it. Okay, looks pretty good. I am gonna go show you another approach that just so we can be more aware. So let's try another approach really quick as far as the marked is concerned. So what we can do instead of a set, we can use an array. So maybe we set this an array. Set this to an array. So we'll set it to zeros for false. And what I'm going to do is a little bit of a trick here. I'm going to say L plus 1. Now, why did I set it to L plus 1? So if I didn't set it to L plus 1, so let me show you. Let me show you something like this. So suppose the array looks like something like this. 1, 2, 1, and 1, 2, 3. And suppose the index is currently at 0. So suppose the index is at 0. Now I need to mark the one after it and the one before it. So I need to mark. So I need to mark I plus 1 and I minus 1. So I think it's okay to say, okay, marked I equals, we'll just say true for now, because this is I 0, right? However, though, I minus 1, so we would have marked, I think I plus 1 is straightforward. I think that's okay in this case. So that would move us to 1. So marked 1 equals true. However, though, marked, this would be negative 1. So if we have 0, 0 minus 1 would make it negative 1, which would make it true. So that would mean that we would make this marked, and that isn't allowed. Let's go over the description. So let's see what they say exactly. Mark the chosen element and its two adjacent elements if they exist. So in this scenario, 1 and 3 are not adjacent. So you shouldn't be allowed to mark 3. So in order to avoid this issue, what we can do is just add an extra space to marked. So then now, so imagine marked would now look like something like this. So instead of having 3 spaces, it would have 4. 1, 2, 3, 4. Now going back to this problem, we would still mark 0 as 1. We would mark this second index as 1, and we'd mark this last index as 1. However, though, but we don't care about the last index. We don't care about it. It's not part of our answer. So that's why it's like a dummy space. So this little bit of I don't know if a trick, but technique is a good idea. And now let's apply it to our problem. So so we can erase all this. One other thing. Python has this interesting what is the word to say? Or interesting. I don't know if practice is the word, but result. Suppose you have something like this. We could have, say, marked I equals 1, and we can do that for all of them. We can say I plus 1 and I minus 1. So this is perfectly valid, but Python has this rule, or I'm not sure how to phrase it correctly, but whenever you have an assignment, this also returns a value. So what I mean by that is we can mash them all together into a single line, in order for us to maybe save some, to be cute or to be savvy. You will see this in some people's code, so I think it's good to be exposed to it. And so basically what's going to happen here is we're going to mark I minus 1 as 1, and it's going to return this 1. So this will be marked as 1, and it'll also return the 1, and then this marked I will be returned as 1. Let's check it. And let's see what happened here. Okay, that's right. So this needs to change. So we need to write if marked I, continue. Okay, let's look at that. That's better. Let's submit it. Now this may or not improve it. I think it will, but in any case, I wanted to show you this because these little techniques that you're exposed to will make you a better developer. So if you found this helpful or enjoyable or educational in any manner, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourselves.